Our next speaker is Alexander Popiak, Solutions Engineer at Parity Technologies. He will talk about a novel feature that he's trying right now on Statemint that allows us to pay transaction fees using assets. Please, if you have any question, don't forget to put it in the Q&A section. So welcome, Alex. I'll let you take it from here.
Thanks, Ricardo. Thanks for the introduction. Yeah, as he already mentioned, we'll be covering adding support for paying transactions and assets, and that's quite a mouthful. So what we will do is jump in with the motivation behind this change, why we wanted this, why we wanted to implement it. So the motivation behind the feature is basically Statement's purpose. So Statement is meant to be an asset store, right? It's a parachain meant to allow you to store assets reliably and keep track of them, who owns what, send assets from one account to the other, and so on and so forth. Either non-fungible or fungible. And that means that we want to not just support you doing that, but we also want to support owning and sending just one value-bearing asset. So if, for example, one of the assets deployed on Statement is a stable coin, and you own some of that stable coin, we want to support the user in being able to just use that asset, send it around, pay for something in that asset, for example, and not have to care about the native currency for the native currency of the Statement chain in order to do that. So if you take the current statement or the past statement and you try to do that, you will run into an issue, which is in order to be able to send your asset around, send it to some other account, you will need to send a transaction, and you will need to pay for that transaction. And paying for a transaction was only possible in a native currency. So now, even though the only thing that you're sending is your stable coin, you need to own some native currency, for example, DOT in the case of Statemint, or in the case of Statemint, the cousin network on Kusama, it would be a KSM. So you would need to own some of that native currency in order to be able to send your asset. And that's the thing that we wanted to change, right? The missing feature is being able to pay for a transaction in the asset that you're sending. And then you can use it purely for that asset. So that's the motivation behind the change. And conceptually, very simple, I would say. We had to overcome two related problems here. One problem being worthless assets. So Statement is permissionless. You can, anyone that puts up a deposit can create a new asset. People have done so on Statemint. There's all kinds of fun things, people playing around with names and so on. I think I've seen Bitcoin on there as well. So you can permissionlessly create assets, but that doesn't mean that they're necessarily worth anything. And even if the asset is worth something, you need to determine how much to charge for the transaction fee. And so the second question that we have is how to determine the price. And of course, these two are interrelated, right? The price is going to be zero if it's a worthless asset. So how do we address these problems? The worthless assets one is tricky to do and very tricky to solve in generality. And so what we did was we just say like, okay, there is a flag that determines whether an asset is self-sufficient, whether it's sufficient. And we will set this flag via governance. So we will allow the governance to decide which of the assets that is created on chain that was put there, which of these assets is sufficient reason to keep an account around, right? So one account can have any number of tokens in it, can have the native token DOT, can have some stable coins, some other coins in it. If an asset is marked as sufficient, that means that this account can exist even if it only contains that particular asset. So for example, one stable coin. So governance comes to the rescue here. And now we need to solve the price, right? So we have an asset that is marked as sufficient, and we need to determine how much to charge in terms of fees. And there are several options on how to determine the asset price, how to determine the size of the fee. And one option that we'd have is include an external oracle, right? We could have highly accurate price data coming in. Presumably, the asset would be registered on some exchange if you want to trade it. But this would add quite a bit of infrastructure complexity. And we would need to run the middleware and so on. And also, the security of the chain now depends on the external data. And this is not particularly desirable. So we did not go for that option. Another option would be to introduce an on-chain exchange. We would control the exchange. It would be fairly accurate, at least if we can attract enough liquidity. So it would be less reliance on external data there, but it would have high complexity in implementation, and it would go against Statement's vision. Statement is meant to be an asset store. It's not a DeFi chain. There are enough community chains that will do DeFi, and that's great, but Statement is not meant to be that chain. So then in the end, we decided to go for something more directed by governance again. So governance comes to the rescue again for us here as well. And we basically went for the initial implementation. We went with the simplest possible version, which is the minimum balance ratio. So when an asset is set as sufficient, right, it means like, hey, if someone holds assets of this kind, it's enough to keep the account around. That the asset will also include a minimum balance that for which this is true. And if an account goes below the minimum balance, it will be reaped. And so this minimum balance will be set. And then also there will be an existential deposit for the native currency of the chain. So for both, we have this minimum balance that will determine whether it's worth it to keep the account around. And the ratio between those two will somewhat approximate the price ratio between the two, and will allow us to determine fees that are roughly correct. So this will not be an incredibly great price oracle, but what we need to do is we need to charge fees that are high enough to avoid DOS attacks, right? This is not about finding the perfect price. This is about determining something that's safe and to keep the chain safe. And then in the future, we can extend this to allow governance to update this exchange rate to allow more flexibility or adjustments or whatever if needed. All right, so now that we've gone through the problems to solve and the motivation, we will jump into the implementation, right? You were promised an advanced talk, so I shall deliver. We will go into the nuts and bolts of how we implemented this feature. In order to do that, I want to talk very succinctly about the transaction flow, right? This is what we will be changing here. So on the right-hand side, you can see that the transaction includes spec version and then some other fields that have elided here, a tip, and then an asset ID. This is true after the changes that we implemented. So that's the first change already, right? This asset ID that's part of the transaction is the first change. So henceforth, transactions on Statement will include this asset ID, and this data will be passed as part of the transaction through the two phases that I want to illustrate here. So there are a bunch of things involved in processing transactions, and I will not go into all of them here, but two key parts are the transaction pool, where a transaction is sent to if you, for example, pass it to a node via RPC. And there, the transaction will be validated. And in the case of the transaction fees, this actually means that the fee is withdrawn, but not as a check. So it checks whether the fee can be withdrawn. And if it cannot be, then the transaction is invalid because there are not enough funds to pay for it. So that's the first step. And then once a block builder actually decides to include the transaction in a block, it will go through dispatch. And there we have the pre-dispatch, which will do the actual withdrawal fee. So it will actually mutate the chain. And then it will apply the extrinsic, the included extrinsic. And then in post-dispatch, it will correct the fee. So this has to do with the weight system of Substrate, where we give a worst case weight estimate for how expensive in terms of computation the transaction is. And we will charge the fee based on that. And then in the post-dispatch, we will have more information on how expensive the transaction actually was. And so we can correct the fee downwards. All right, so this is the rough transaction flow. And I will sort of try to point us back to this when we go through the implementation so that you have some idea of where we are in the process. So next, to illustrate, I want to divide the implementation into 3 parts. The first one being balance conversion in the assets palette, which is within Substrate. So in order to do the conversion between the native currency and the asset via the minimum balance, we needed to extend Substrate to allow for this because it depends on data that is only available within the assets palette. Then a second piece is to write the actual palette in Cumulus. It lives in Cumulus right now. There are plans to upstream it to Substrate, but right now it lives there. And there we built the actual fee charging logic and the actual signed extension that will define the transaction format, what it looks like. And then we need to wire it all up in the statement runtime. We need to define where to put the fees that we charged. We need to assemble all the pieces together to make a coherent whole. And to help you get even more of a sense of how this all fits together, I sort of have an overview here. So on the top left, we have Substrate with the assets palette, where we introduced this balance to asset balance type that for the conversion. Then on the top right, we have Cumulus with the new palette that we built, Pallet Asset Transaction Payment. And this includes the new signed extension, Charge Asset Transaction Payment, as well as a fungibles adapter that provides the default implementation for how to charge the fees in assets. And then we in parachains common, which is like a shared crate between the different parachains. Within the Cumulus repo, we have assets to block author, which is one way of one implementation of what to do with the assets. So in our sort of MVP implementation or first implementation, we just pass it to the block author directly instead of doing more complex things like gathering it in a pot and then paying out based on that, which is what we do with the native currency. And then at the bottom, we have the statement runtime, right? We have the pallets that we instantiate in the construct runtime macro, where we instantiate both the transaction payment and the asset transaction payment, because we need both in our runtime. Then we implement the configuration for our new pallet, where we sort of plug everything together with the fungibles adapter and the balance asset balance, the assets to block author, all of those together. And then we have the sign extra, which delineates the signed extensions used for transactions for this runtime. And there we swap out the previous transaction payment one and put ours in. And this is because we wrap, like our signed extension wraps the one that is present in Substrate and actually passes on to it, which you will see in a moment. All right, let's, for the rest of the time, let's jump into the actual code. It's a lot of code, so I've tried to like gray out the parts that are not going to be as relevant and sort of point out, highlight the ones that I want to talk about. So one thing that you will see here is the asset.isSufficient. I already mentioned this, right? We need to check that our asset actually has value, and we do this by checking this flag that is set by the governance. So this is one crucial step, and this flag is only available within the Pallet assets. It's private to the module, so we cannot access it from the outside, which is why this implementation lives there. And then you can see f : minimum balance. I've been talking about the native currency a lot, but in principle, this implementation is generic over any kind of fungible. So you could have a different, and any any implementation of an asset basically that implements the straight can be used to convert from, and then you can convert to the chosen asset balance. And then at the bottom you see the actual equation, which is super simple. We just multiply our balance, our incoming balance, with the minimum balance for the chosen asset that we want to convert to, and then divide by the minimum balance, which is going to be the existential deposit for us, and that's it already. So this is the conversion. This conversion will be used both in the withdrawal of the fee for the initial fee, as well as in the corrected fee, because both times we need to convert. So in terms of the transaction flow, it's used everywhere. So then here is some choice pieces of how we wrote the pallet. You can see that compute fee is actually reused. This is what I mean with part of what I mean with the wrapping, right? We just reused the logic from pallet transaction payment to determine the fee. And then if it is 0, we note this because in case it is 0, we will not refund anything at the end. And also, it doesn't really matter whether an asset was passed or not. If the fee is 0, then we're not going to pay anything anyway. Then we check whether there's an asset ID configured. If it is set to none, we skip to the last point. But if there is one configured, then we will use our on-charge asset transaction. So we will use the asset to pay. And if none is configured, then we will also just reuse the implementation that's already present in Substrate. So there's another wrapping there. So what does this implementation look like that we built? Basically, it calls the converter, as we already saw. Very simple. And then there is some checking with can withdraw that I grayed out. That's not super important. And then it just uses the configured implementation to withdraw the fee from the account that sent the transaction. So you can see that here, right? This is the fungibles adapter. So the default implementation should be swapped out in principle. And then the first thing was withdraw fee, right? That's what we do before we actually execute the transaction. And then this is the correct and deposit fee. So this is what we do afterwards. There we also convert the balance, we convert the fee from the native balance type to our asset balance. And then based on the paid fees and the converted fee, the final converted fee, the corrected converted fee, we split into a final fee and a refund. And then we refund back to the sender of the transaction potentially. And also we send the final fee on to the implementation. Note this is generic again, right? And that's why we have that assets to block author implementation that I've also already mentioned, where we just take the block author and we just pass the asset onto that author. So very simple implementation. And now we need to put all of those pieces together. And that's what we see here, right? We see the configuration for the new pallet that we introduced. Our fungibles implementation will be assets. Our on-charge asset transaction is this combination of the fungibles adapter and the converter, the balance converter, and the assets to block author, all of those together. And then at the bottom, you can see the signed extra, where we swap out the old charge transaction payment, and we instead include our own charge asset transaction payment, the wrapper that we built. Alrighty. So as I already mentioned, the handle credit that we have right now is super simple. And so in the future, we might want to improve on that by putting them into a pot, or and then once we have these pots, right, and if we get a lot of assets, right, if the parachain is successful, we might get a lot of assets, and maybe they all value bearing, and we want to support paying transaction fees in them, then we would get a lot of complexity every block if we iterated through a whole list of them to pay out the block author. So we might need to implement something like just paying out the top K pots, like have a priority queue kind of implementation, and then only if enough funds are accrued would they be paid out. So there's some ideas there that we might implement. And then we probably want to be able to set the balance conversion via governance, right? So that in case this is changed, or in case the value changes on the market or whatever, those kinds of things, governance can react and course correct. But the future is uncertain. This is not set in stone. We're open to feedback and ideas. So let us know if you have cool ideas for how to make this more secure or more user-friendly and so on. These are the future plans. And now I would be ready to go into questions in case you have any. Thank you for your time and attention. And maybe Ricardo already has some things.
Awesome, Alex. Thank you. I'm just amazed about this new idea. I just want to play right now, just to pay with assets. We have a few questions from the audience. One of them is, have you considered other kind of governance over what tokens are considered self-sufficient? I can imagine a token curated registry that controls the list of sufficient assets.
Interesting idea. I think I've taken the governance mostly as a black box here, and be like, okay, we have some system that decides decides for us how which assets should be marked as sufficient. This is an interesting idea. So part of the reason why I did this is that Statemint does not have its own governance. It just it's sort of remote controlled from the relay chain governance. So this sort of token registry could be implemented in principle on I guess it would be implemented on Statemint, because that's where you have all the assets. I think it wouldn't make sense from the relay chain. So we'd have to see. It's an interesting idea worth exploring. Definitely.
Great. Yeah, I agree. Sounds really interesting just to see that we can probably use other type of governance just on Statemint for this kind of assets and payment on transactions. There's another one, and I think this may be the last one. So if it's possible to pay the transaction fees in another parachain or even on the relay chain using assets from Statemint?
The transaction fee payment is synchronous. It's part of how the transaction is processed. And the relay chain does not know anything about assets. So I think for the relay chain, it would be very difficult to do this. I don't quite see how you could pay for relay chain transactions this way. Statemint is supposed to be exposed by XCM, or will be exposed by XCM, and so it can serve as a reserve for the assets that are on Statemint. So what is definitely imaginable is that someone does a reserve-based XCM of assets on Statemint to a parachain. And then, of course, that parachain locally is free to allow payment of transaction based on those assets. Like, that's definitely possible. So they could probably reuse the stuff that we implemented to allow for this. Of course, that would depend on the parachain, and it's not. So what won't be possible is paying sort of on Statemint for the transactions on another chain. Like that won't be possible, I don't think. But of course, the reserve-backed tokens on the parachain that are actually sort of backed on Statemint, I could easily see that someone implementing that. I think that's possible and plausible.
Awesome. Thank you so much, Alex. It was really great talk.